All right, let's see. All right, concatenate non-zero digits by and multiply by sum part 1, easy. You're given an integer n, form an integer x by concatenating all the non-zero digits of n in their original order, non-zero digits. If there are no non-zero digits, x equals 0. Let the sum be the sum of digits of x. Return the integer representing the value of x times the sum. I don't know what's going on. So concatenate all the non-zero digits of n in the original order. So you're concatenating 1, 2, 3, 4. And then you're multiplying that by the sum of these digits, which is 10. Okay. Okay, so this is 1 is the concatenation of non-zero digits, and then 1 is the sum of the digits, so 1 times 1. And is 10 up to 10 to the 9th, so it's up to basically 9 digits. Okay. I guess I convert. I guess I just parse the digits, right? So it's probably use a while loop. Simple parsing. I'll use total because sum is actually a function name in Python. So total equals 0. And then I guess I do the concatenation. Let's say non-zero is concatenation. And I want to parse it. Kind of want to parse it left to right. It's using mod 10 to get the 1th digit and then remove it. So let's say while n is greater than 0, the 1st digit is n mod 10. Guess I kind of need to know which place value it is. If the 1st digit is not 0, then the total increases. I guess I don't really care, actually. Total always increments by the 1st digit, even if it's 0. And then the non-zero value is equal to the 1st digit times the place value to the power of 10. I guess place value should be starting at 1 in that case, 10 to the 0. No, place value should start with 0. And then increment the place value. So if this was like parsing this thing, it's at the 4. 4 is the 1st digit, so it's 10 to the 0. And then the next time it sees this 3, 3 is the 10th digit, so it's 10 to the 1st. This is the wrong order. 10 to the power of place. I don't order operations, just do 10 to the place first, right? And then I just return the non-zero calculation times the total. I think that might be right. No, that's not right. This while loop never stops. And you actually do n divided equals 10, so it removes that 1st digit. Unfortunate. So iterating over the loop n is this number. 1s is 4. Total increases by 4. If the ones value is not equal to 0, then non-zero is, no, whoops, it should be plus equals. Yep. So this calculates the 4 times 10 to the 0, 3 times 10 to the first, 2 times 10 to the second, 1 times 10 to the third. Adds them all up to get the non-zero value of 1, 2, 3, 4. Yep. Okay, cool beans. So use a kind of for loop to iterate over the digits of n right to left using kind of value mod 10 to get the rightmost kind of ones digit. Use appropriate logic to work with that digit into a running sum of digits, which I call the total, and into a non-zero value, which is kind of the about the n without zeros. So for example, if I have 1, 2, let's say 0, 3, 0, 4, this can be 4 times 10 to the first, 10 to the 0, plus 3 times 10 to the first, plus 2 times 10 to the second, plus, no, sorry, yeah, plus 1 times 10 to the fourth, 1 times 10 to the third. And since it works right to left, I have to keep track of the place value of the next non-zero digit to incorporate that into the kind of non-zero value. This was a more traditional kind of left or more traditional right to left where I could just not worry about that. I would just like not have to take into account this place. But in any case, yeah. Was there any other way I could have done that? Not Nothing comes to mind. I guess maybe using an array to store the digits somehow. It's all the same. It's pretty fast. Complexity scheme O of n, where actually O of d, where d is the number of digits in the number. In this case, it's 9 digits, so O of 9, I guess. Space complexity scheme of 1, since no extra space is needed. Cool.